Okay, just quickly, if I summarize what you have learned so far from before study break, of course, we started planning process, like how transportation planning process are being done. We talked about transportation data, travel behavior, how we can interpret those in the second lecture. Then we started discussion on the multimodal transportation, try to give you some sense of the planning consideration for BRT, Bus Rapid Transit. And follow up to that, Mahmood did one lecture on transportation performance analysis. So you learned about how we do this bread and butter engineering kind of stuff for like checking on like transportation performance based on the volumes and so on and so forth. And today we'll shift our gear. So we have some understanding of like the overall transportation planning process. Now we'll try to go to the modeling piece, like which is one of the fundamental piece for doing large-scale, long-term regional transportation plans. So that's what we'll be discussing in this class. Do you have any questions so far for what we have covered? So before I go to that lecture, I would like to go to the team project a bit more in depth. I have a question. Did you guys got my email on February 15th? With the lecture and YouTube for my missing classes? Some people got, some people didn't.
Not on the 15th.
On 15th?
No, not on the 15th.
Not on the 15th. Okay, anyways, now you got one. So we uploaded the video link, those who missed BRT lecture, because that has some things to do with this. And today also we are videotaping because a couple of students from the SHIFT conference is not there. So we will try to upload that in that channel. So anyway, so I will introduce today in a more deeper way. We have the flow, like some understanding at the very beginning of like my last lecture of what the project could entail, and we have the group formed. Now I will go a little bit more on actually what is the expectation and what you are supposed to do. Okay, feel free to ask a question anytime. So basically what we are trying to do in the team project, both engineers, planners, working together, grad student and undergrad student, is trying to identify a new BRT corridor. New BRT corridor connecting Bedford West subdivision, which is a new subdivision if you don't know, is growing, the fastest growing community, and to the Scotia Square. So that's the end point. We know the origin point, we know the destination point. So this is in alignment. This project is we are running for the last 5 years, and hope most exciting piece is the HRM actually took that lead and now running multiple corridor study to do similar kind of things, but they are doing it in a different, within Peninsula, in a separate project, which is WSP is running for Göttingen. There is another one Dylan is working on, more on Clayton Park to downtown. But in our case, it's more BRT from one of the suburban core, and you will try to connect that dot from the origin point of Bedford West to the Scotia Square downtown, or even in the BRA. So I have given a very detailed instruction, like what we are expecting, but that's the context. The HRM has moved on this. They have IMP, Integrated Mobility Plan. You will see similar ideas actually coming out of these classes. They came actually in every last 5 years in our year-end presentation. So it's just an exciting time to do this exercise, and there will be consulting works going on too. So you are, as a consulting team, you are working on it. So please give a name of your consulting firm. So that you feel, bring that understand, like the kind of excitement on that. But what I am looking for is a very specific pieces. One, you'll be collecting, in the second page you will see, you'll be collecting background materials, information, maps, data for the study. I uploaded some transit ridership data for all routes. in HRM, so that's in there. But you can also get data from sensors. For example, if you are looking for travel demand, you can look at the Google Maps. You can look at many other sources as you go. The scheduling, new scheduling from the Metro Transit ridership. You should keep your project manageable though. Like I emphasize on that. Like, you know, this is a 1-month project. You have also a limited time budget. So make sure you are not actually trying to do a lot of modeling that I will be teaching here. It's more about a process of coming up with a corridor proposal at the end from this process. So the first step of that process is collecting this data, base map and all the things, and we'll try to also keep whatever we get to manage for you. IMP could be one starting point. Look at some of those plans, like to see what's the intent of the piece. Second objective is you will try to find a potential corridor. And when I mean corridor is a continuous line. That's how I differ with HRM in certain ways. So continuous line from Bedford West to the downtown. So what that continuous line or continuous, like the route, or not route, like the corridor it could be. Now you have only 3 options, to be very honest, with some variations. Bedford Highway, 1 or 2, or somehow 1 or 2 in combination with the Dunbrack Main Avenue. So generally these are the 3 corridors we are talking about. So you first get this higher level corridor analysis with some sort of a screening mechanism with certain criteria, which corridor you feel that is most beneficial, that serve everything that you learned from my different lectures, that serve the travel demand, that reaches, that has a higher coverage, for example, more residential area or destinations being served, or cost constructability. Like for example, like if we are looking for some dedicated portion of that corridor, not the detailed design, very high level, the corridor level, like which corridor to prefer on, that's what I'm saying, that select the most promising corridor through a screening process. Right? You have to identify some criteria, some numbers, sometimes it could be also qualitative, like oh, there will be a huge high, medium, or low land use growth potential, because you can't measure land use growth potential, right? But you can at least, like somehow within those corridors, you can know Bedford Highway, for example, might have a low potential to densify given the land use spatial structure. But the Clayton Park through that might have more, or Highway 1 or 2 doesn't have that. So you have to come up with those kind of like the evaluation. And I put a lot of Hamilton's BRT in your leading list. You will see that some of the consultants work there, like which will guide you through on this selecting. 4 or 5 criteria, I would say, not too many, and it will be different depending on each of the group composition. If there are more engineers or more GIS person or more planning land use consideration, that will be different, and it's okay to be different. Diversified way of evaluating. Doesn't need, every group needs to be doing that in the same way. You will judge on your group discussion whether my ridership is more important, or coverage more important, or land use impact more important, like that way, or the travel time potential to connect mobility more important. So you can come up with your own way of evaluating criteria. So that's the very high level. You select the corridor first, okay? And then you will think about a bit on the BRT technology assessment, like what type of things. BRT is, I told you, it's a package, right? So what type of thing you might think that it's innovative but at the same time practical to consider. We cannot like put, oh, every bus should have a security camera. We have a concern for the security camera, right? Or we have an automated vehicle locator system in Metro Transit, maybe that's good, like we will be putting that. So, or not every intersection should have a TPM, like traffic priority measures, right? So you choose some sort of whether Wi-Fi or left door in the buses. So you look at the available technologies, bus, and all the things that you learned in the class, look at it and try to come up with some reasonable set which you want to do. The next stage is route selection. Once your corridor is finalized and you know some of the technology, say I will put some TPM, traffic priority measures, or queue jumping, or some design changes in there, then you finalize the route. You select, you refine the route, like the exact route, and you do not do evaluation on that. It's more you see whether that's feasible for each. You propose in certain ways, right? So that's, and then select the final BRT route connecting a specific suburban area and downtown area, and you put rationale. Why certain decision you made. You give some examples. You don't need to design every intersection, but some of the intersection, oh, I consider this 4 intersection needs queue jumping. This is one of the example solution. A SketchUp or some sort of any way of even hand drawing, whatever resource you have. So think about your resource within the group, within the consulting firm. So you put that in. And then finally, it's not then, it's finally what I want is the ABRT package that serves from Bedford West to downtown Halifax, and some group might think, oh, it's not just the Scotia Square, it should connect the institutional district like Dalhousie or BRA. That's okay, but we want that final recommendation as a whole. At the end, whatever package you did, you should provide some sort of, sometimes some students for all these projects do SWOT analysis, for example, strength, weakness, threat, or opportunity analysis. Bring from your field, like either industrial engineering or civil or planning, like your field kind of learning here as well, maybe visualization from the GIS, like showing that, oh, it works. So whoever, whatever strength within your consulting firm, you have, show that, like, this is our package and this is how you should be doing that somewhere else. So that's generally what we are expecting. You have to produce a final presentation one month from now. I think it's April 6th or something, and then the report thereafter. Any question on the project expectation? Is it clear so far? Sounds good? You guys are excited? Okay, I will invite HRM, like generally, or Metro Transit, or planners, engineers in the class, just so that they can see and learn what you have done. Keep your project manageable. Once again, keep your project manageable. Think very strategically. The need to make a case for the selection, the evaluation that you did. We don't need to do all sort of, say, arena simulation to see like whether it's happening or not, or a 4-stage model. You don't have that. You have some certain things that you can maybe visualize, GIS, see how much ridership potential, current ridership, future potential, those kind of things. But keep it simple, keep it sequential and structured. Like the evaluation should be structured, some thoughts. Oh, I have these 3 criteria, and you will see all of those things reflected in those, say, Hamilton Rapid Transit Project reports. You will see that, like these guys, they did this way. So it's nothing new. Like you don't need to go to this. It's a practical project. It's quite a implementation type of a project, and you will find this kind of things. Waterloo have that like similar kind. Even within a month or two, like there will be a parallel similar kind of report will come from the Dillon consultant. So they are doing the same similar kind of work as well, and you'll be surprised. Most of the work that's being reflected on there looks like the things that looks like the things that we did in the class, because one of the leading consultants was in this class for that project, who is still employed by the Dillon. So I saw a similar kind of title. Okay, corridor analysis, screening process. So they are doing the similar. So I think that training is worthy of going through this exercise. Any question on the project? You should have multiple group meetings, please. Like just sit down and subdivide work, and that's what will help you. Is next week you have this interim report. It's not interim, initial report, I would say, which should have some, say, introducing the material you collected, what data you are considering, a short list of activities you performed or you thought about, like how you divided your work, some work plan with term like the work plan with tentative timelines, maps, visuals, whatever you started collecting. Mainly what I'm looking for, the main piece is a table of content. Generate upfront table of content. It can change, like it can be modified, revised, but that will give you some sense of, oh, this is what we are doing, and these are the responsibility of, say, Lena in my group, or Rachel in my group, like, so that we know, like, and you know also, like, you started that team project. Okay, so maximum 5 pages, but mainly I'm looking for a table of content and some activities that you planned or performed. It's not on the progress, it's more on how you are envisioning like performing the task and getting yourself running. Sounds good? And that's 5% of your presentation. And March 23rd, we'll be talking in class some of the progress report, like some of the progresses by then, what you have. April 6th, your final presentation. April 10th, your final report due. Sounds good. Any question? Clear? Okay, this is a good project. It's a good project, and I found student really contribute with. Be brave. Be brave in your recommendation. That's okay. Academically, that's be brave in your recommendation. Be brave in, say, even I hinted that the Cogswell should be the new terminal, bus terminal. Be brave, show it if it's good. But also be practical. Like we cannot say, oh, all roads needs to be demolished to do this, right? But there are potentials. Say Cogswell, it has not been done yet. So there is a potential to do that. Or some of the roads can be dedicated. Look at some dedicated. BRT, look at BRT attributes. I don't want a transit corridor. I'm looking for a BRT corridor. So you know what BRT is all about. We don't need many stops, limited stops, right? But we need some priority measures so that they can bid the auto travel time. So be brave, be imaginative, but be practical as well. Like we do not have like billions or zillions of dollars to get the BRT. Give a BRT plan. Because I am assuming the next, after this billions work, HRM will go for Bedford West for RFP. That's just a prediction, don't quote. Any question? No? Perfect. Let's shift the gear to another important piece that we need to learn is travel demand forecasting model. So this is one of the exercise most municipality does, and many state, particularly in the United States, they have started doing that, like at the provincial level, state level. Even in European country, they do at the national level. So there is this broad, bigger model, but at the same time, some people even use the same concept or same sequential modeling piece for smaller project, say library. We are building a library or Nova Center. We have to do a traffic impact study. So we have to estimate what is the travel demand would be. So the model is not scary. It's just trying to understand how much travel demand a particular land use, a particular like the region will be generating. So that's what we call travel demand forecasting model. And I think for many years, since the 60s, like there is this established 4-stage model we call classical 4-stage model, which we'll try to learn here. And you will hear from many municipalities, oh, we have a 4-stage model. We have a model we are generating, And as a planner or as an engineer, you will hear both. So as a planner, what you need to know is how does this model works, so that you can utilize those results or advise them, oh, you have to consider that so that we have a better number. You'll see even IMP, Integrated Mobility Plan, there are some model target, like by 2030 or 2050, how much modal split we are expecting. That's coming from this model that they have developed. So we'll try to learn these 4 stages, which is trip generation, trip distribution, modal split, and traffic assignment. And I'll explain one by one everything. Please raise your hand whenever you are seeing I'm losing you, you are not understanding. It's okay to do that, because I know many of you might not have the background or those kind of things, but it's easy. I will try to make it easy and really to understand the core principle, the theoretical principle, and how to do it as well. It's easy in various ways. It's really possible, doable, and people do that on a daily basis, particularly at the small scale. This 4 stage, like the traffic impact study, or a bigger scale, then we need many people to get involved, right? One of my master students developed the first version of Halifax one, so it's not as scary as you can think. They can do this thing. And one of the M-Plan students started this process as a directed study. So it's possible. So whenever you are seeing that, oh, Hassan, I need a clarification. What does that mean? How do you do that? Raise your hand. Okay, we'll go in that way. I want to clarify at the very beginning all the core concepts so that we don't lose, because it's a sequential process, one stage by another stage. So today I will discuss only 2 stages, trip generation and distribution, and what are the methods there, and how do we do both of them. So, and then in the next class there will be other two stages. Okay, so the reading is, please read, particularly for this one, read the Meyer-Miller. I gave the page numbers, as well as for more introductory. This is much easier to digest, the Banks one, the engineering one. But both will be very small reading. Please try to do, particularly Meyer-Miller will give you a full sense of how we do it. My first question: why we need trouble demand model? Why we need, just guess, why we need trouble demand model?
Because we need to use it to plan.
Yeah, we need to use this for plan. We need to know the demand. How? We need to know the demand. What should be the lane size? How many, whether we need buses or whether we need transit routes. We need to, for any strategic big plan, we need to know what is the demand. Unless we don't know the demand, we can't plan accordingly to maximize our resources. So planners use this model for transportation system and try to see what are the consequences of the changes in the system. Most important thing is, what is most interesting is we build model once, and then we can use this model. These are the scenario-based model. Then we use alternative scenarios. Say we want 50% growth in downtown core. Then we use that scenario to see what will be the overall system impact. Congestion, level of service, all that you learn, we see that whether that's a good idea to do so. So we can, the land use scenarios, we can add them in employment growth, population growth, or even we can test, for example, if we need, whether or not we need the third bridge. We can test, we add that link, I will show you, we add that link and see how it changed the overall system movement, overall traffic movement. So we can say it's actually maybe benefiting this area, these zones, this downward connection, but maybe not doing well in other areas. Or Cogswell transformation. We are changing Cogswell to a 10-lane. We can put it there in the model, see the scenario, how it's performing. So it gives us the cost, it gives us the results. So that's why it's an important piece. Now, before I start, four-stage model, you have to understand model is the abstraction of the real world. Model doesn't bring every key details of the system. So it's an abstraction, it's a system abstraction, it's a behavioral abstraction. System abstraction, what does it mean? Say we have many roads, but we cannot model every cul-de-sac. We can, but it's costly, right? You have to then network, create those networks, it's many. So, but we can abstract, or maybe major roads will be fine. Maybe arterial roads will be fine for our modeling purposes. Maybe highways are fine. Maybe main connectors are fine. So we can abstract them. We cannot maybe micro-simulate every person and their behavior, like whether the demand is based on you guys, right? So what time you start, what mode you take, those are the important questions, and that's what we're trying to model. So we also try to abstract our behavior, right? We cannot like get every behavior, whether you are doing online shopping, that's why you are not taking trips. We can't bring it in the practical model. We are doing that for our research purposes so that we can improve these models more and more. But here I will be talking mostly the ones that we use in industry because of the practical reason. So just you have to keep it in mind. So you can see the model is nothing but this is an abstraction. This is a model. This is a model, right? But this is an abstraction of the system. Abstraction of the system. So this is a model. It's a physical model. We try to abstract the ocean, we are representing that. Then we have this elevation, the contours. So we are working with. So this is more a mathematical model, a computer model. The same concept, the same way of like doing that. How do you do that? You create a system. You create transport system, transport network within that computer system. And you try to, let's go quickly then, yeah. So you create a transport network. It's a Toronto's example. I should have started using our Halifax one because we have now that one too. So you represent all roads, and this is more complicated because they are doing it for many years. So they make it much more representative of all of their roads. But this is what you get. All the roads, we connect them. It's a GIS. How many of you have some GIS in planning back? It's a GIS. It's a GIS, much simpler tool. ME is much simpler tool. It's only for transport network, only for transport modeling. Similar idea. It has a topology inside. It's a linear. These are the linear feature. Okay, I'll come one by one. These are linear feature. It says, but it has much more functionality in it. Like the impedance is much more nicer. The assignment procedures nicer. For the industrial folks, you guys did some simulation in the arena or like right? So it's a similar kind. The process you probably have done, say McDonald's, how they serve, like that queuing. So it's a queuing theory. It's the same kind of a process. So it merges. That's why it merges these all concepts in one place. So it's similar kind of, and I will go one by one so that you know. So what first we need to do to abstract is we first need to create this street network. That's number one. Street network, which is nodes and edges, right? Nodes are our intersections. See, this is our intersection and the link. And link, and why two lines? Two-way, so that we can flow people two-way. It's a flow model. For if there is any from civil engineering, the water modeling, the water flow modeling, similar kind of things. So for us, it's easier. For us, it's easier because it's a straight line. So you just create the way you do GIS. Even there are functionality from the GIS street network, it automatically transfers to the ME network, like the one we have. If you guys want to check it out, please come to the lab. I will show, like just to play around. I will give that access to. It's a very costly software too, but we have this in our lab, so you guys can. So that's one thing. So we represented the transportation links first. That's the first step. Second is we need to load people. Load means like that origin and destination. Remember I was talking about origin and destination many times. Just a second. Okay, Okay, so OD, origin and destination. So I was talking always this OD, origin is our residence, is home, and destinations are our employment, like generally, because that's our main trip. Work trip is our main trip. There are non-work trip too. So to represent them, what we need to do, we cannot represent every home. Right? So that's why we are abstracting. What we do is a zonal system. So all zones, which is kind of like those who know census data, census tract is a zonal system. It's an imaginary piece, right? Or dissemination area is a much more smaller piece. So same way we do what we call traffic analysis zone, TAZ, traffic analysis zone. So we create some zone so that we know, oh, downtown zone, say here, that downtown area, this is one zone. So we create multiple zones, many zones. We subdivide, say for Halifax, we have now 118 zones for now. So we create maybe some zone here. Usually we try to go with the dissemination area. I will tell you why, because then we can get data from census as well. So we just create those zones and assume there is a centroid for each of those zones from where people start on an average, instead of trying to model every home. In our research project, we do every homes, but not for the practical ones, like those who are in using the industry. So we are still in the zonal basis. So these are the two basic principles you need to know at the very beginning. So we represent system, well, that's the system representation. Now there are behavioral representation. Right? Behavioral means where you go. Right? Your origin, your destination, by which mode, by which route. So we try to abstract them as well. And that is for stitch model, which I'll be explaining now. So trip generation is how much production each zone does, how much trip each zone attract, and where they go is your distribution, and that's how we go. Okay, so question? No. Okay. So we do, for that behavioral representation, we do also many classification, because there could be time of the day issue. Like what time we should be modeling. AM peak period, midday, PM peak period, evening period. Usually, for the smaller communities, for the smaller region, people just go for the AM peak or PM peak. Why? Why we only model AM peak or PM peak? Or why is sufficient enough?
Usually that would be the daily peak, like that's the maximum amount you get.
So the maximum demand, if we know the maximum demand, our system needs to design to satisfy that maximum demand, so that's why we are fine. So that's the initial general idea. That's why we do usually the AM peak or PM peak, because we model, we know the demand, that system needs to be designed for. But there is increasingly a push that we should also think about midday and evening because of the aging population. Because we need to serve them, they might need a different kinds of transit accommodation, so we do that too. Like we started even 24, our model, Halifax model in our lab is 24 hours. And 24 hours is also important because these models are no more only for doing transportation planning, meaning construction or plant preparation. These are also emission prediction, energy use prediction, right? How much PM 2.5 or greenhouse gas. We have all these things. Once we know all the trip demand by link, we can easily create, generate the emission, which is becoming mandated. Even in US, it's already mandated for any large project. Emission estimates you have to offer, but now Canadians are also putting any infrastructure funding. If you have to also provide how much improvement you are doing for the greenhouse gas reduction. So this model can be used. So we started with 24 hours. There are also some way, the consideration you have to think about the trip purpose. Home-based work, home-based school, non-home-based trip, and home-based other trip. So we have to understand, I will go one by one. So we have to understand also trip purpose, where we are going. The purpose is usually based on, say, if we are coming from home to work, meaning what it is our work trip, right? Our destination define our purpose. School trip, this is our school trip. This is from home to other, means shopping, recreation, all the discretionary activities, right? So we have to classify them so that we know. And for a simpler model, we just do work trip and non-work trip. Means home-based work, and this is commute trip to home-based school, and home-based others, and this is non-home-based others. Like non-home-based means from school, you are going for grocery shopping, recreation, or you are going for a yoga practice. So we all lump together like in one trips, because those are the important trips too, so that we can get that. So we lump together all of those. We can also do weekend model, weekday model. Typically is the weekday model we do, weekend model, unless there is other reason for that model to serve, we don't do that, right? We can do, without doing all of this modeling, we can also do simple trend analysis, right? Instead of four-stage model. We probably can also do a trend analysis. What is the trip demand overall in Halifax? This is the mode split for multiple years. Then we can just do the trend. Some people does that. Even Halifax, or Nova Scotia government had that kind of a very simpler tool as well. But four-stage model is more preferred tool. Traditional modeling tool is the four-stage model. Any question thus far? Okay. So this is the four-stage model. So trip generation is our first component, trip distribution, mode choice, and trip assignment. So what do we do, generally speaking, just to give you in a nutshell, what do we do is we know the population distribution and employment distribution by zonal area, right? That gives us some understanding of how much trips are being produced by each zone or attracted to each zone. In the second stage, we try to link them wherever they are produced, where they are destined to. We do that. Third step, so we know the trip links, like the end-to-end, the network flows. Then we try to see whether they are taking transit, auto, or other modes. And then trip assignment is more route choice. Now we know they took the auto mode, for example, we separated OD matrices, auto versus transit. Then if auto, which routes they are taking. So we establish that and we run this entire model. What we get from there is link by link origin destination flow. We get the travel time from each origin pair, OD pair, from say Bedford West to Scotia Square. What is the travel time by auto? What is the travel time for transit? And costs. Like if there is tolling or other kinds of things, that can be. So we get all of those. We can get emissions. We can get general network performance, the overall region. We can get specific OD pairs. We can get many kind of things from the base model. So base model is business as usual. We call it business as usual model, BAU. So that means we didn't change anything. We established the model. This is our overall performance. And the use of the model is we change some of the network. We add maybe a bridge from here to there, right? We add and see if it's improving. Or we add a new highway. Or we add a new transit network. And then we run again. We get that same output. So this is external. This is only internal, external to the model. And then we analyze whether we improved it. You got the general picture? Okay, let's go inside one by one. So this is another way of looking at it. So what we do for each zone, we try to understand what is the production. We try to understand, so trip generation means this both, production and attraction. Some zones produce, home usually produce trips, right? And employment area attracts. So this is an abstraction way for us. And so we get for each zone, how many trips produced, for each zone, how many trips attracted. Now we know by zone, right? We know each zone, say in an urban area only 2 zones. We know how many, 3 zones. We know how many produced here. Let's clarify this. This will help you. Say we have only 3 zones. 1 Bedford, 1 Dartmouth, 1 Halifax Peninsula. Let's assume that that's our world, right? So in the first stage, what we do, how much drip these guys are producing? Bedford. And I will give you a definition of production and attraction soon. And how much they attract. Attracted means for the job they brought in. How much produced, how much attraction, how much production, how much attraction. So we know that. Now in the second stage, but we don't know the trip, we just know the generation of it, right? Second stage, we try to see, oh, if there is a 50 trips generated here, how many of them is going to Damat, how many of them going to Halifax Peninsula? That's the distribution. So then we get the trip, the both end, right? In the initial, it's no end. So we know the flow, right? That's why you will see there is no connection here, only how many going out and how many going in a way. And then in the second, you can also look at the notation. So it becomes T, zone 1 to zone 2 is J, zone I to zone Z. So we get the distribution trips. And when we know the number of trips going from one zone to another, the next stage is modal split. Third stage is then we go auto or transit. So we know that we separate them out. Sounds good? I'm trying to come in a different way, same explanation, so that it's crystal clear on set. So once we know like which mode they are taking, then we find out which route they are taking. And we cannot observe, by the way, all of those things, right? We cannot observe. Then it will be huge. We can observe now though with all the smartphones. So people are thinking about like a different way of modeling, but like the time we established those models, we couldn't observe everything, like where people are going, how they're going. So this is a one way of approximation of the demand. So these are the 4 stages. So final stage is this trip assignment. So we'll learn today first 2 stages, like what are the alternative methods of doing that. Okay? This is just to know you, we can do more aggregate level model or more disaggregate level model. Aggregate model is what I will be mostly explaining to you, meaning zonal level model, right? Zone is an aggregation of a lot of people, right? But we can also do individual level model, which is more research level, I would say, like by person, we can also do that. We started like learning on that. But zonal model is our discussions. So now I'm just backtracking. We know in a nutshell all the modeling components. So this is the first step I told you, like to build the network. We need to know the nodes, links, zone centroid, zone connectors, and origin destination matrices. So these are coming from our network, and origin destination matrices is what we are creating for our 4-stage model. Right? Sounds good? So these are that I already explained on the basics of network. I showed. So this is how it looks like in the software. There are many types of software. It's not just the AME. There is another called Visum, V-I-S-U-M, a German one, which HRM use. We have that as well in our lab. There are Cube, there are Transcad. Visum and Transcad is more GIS compatible. But ME started to be more GIS compatible, but in US, Transcad is hugely used, or Visum is usually used. I was more trained on AME because it's a Canadian product. One of the professors at University de Montreal developed in their transportation lab, and then he left the job and became millionaire on that. So, but anyway, there are more functionality in AME inside in terms of to play with for the research students. So I like AME to be used for our places. So these are the example of the zone, and you can see zones are usually predestined. And if anybody has seen HRM geodatabases, you probably have already seen traffic analysis zone layout there. we developed, one of our master's student did, and some of the HRM stuff, we find that. So it's already there. So usually you will see more smaller traffic analysis zone in the downtown core and more bigger in the suburban and rural area, which is reflective of your census tract as well, right? So that we can capture more people living inside, we need more finer details of the movement for the downtown core or where people live or work than the other areas that usually maybe there are a lot of parkland and other kinds. That's why it goes. Usually it's given, like I'm not explaining a lot on that. Usually it goes with the dissemination area or census tract area because we can then borrow some data. Data is an issue. And the data we are talking about here, the data that we will use, we talked about that in second lecture. So that travel survey, origin destination survey, remember I showed all the TTS, Transportation Tomorrow survey, or NovaTrack survey that we are doing in Halifax. So those are the data source for developing those models, the behavior, the trip generation and distribution. That's what we do. But what we do is simply first network and then also the zonal piece and then we try to do the trip generation. Okay, let's start with, so far, do you have any question? You got everything or nothing? Sounds reasonable so far? Okay. So trip generation, let's start with the definition. So in trip generation, it's simple. We are trying to predict the number of trips produced by each zone or number of trips attracted by each zone. Now let's try to understand what is production and what is attraction, because that has a meaning in our modeling realm. Before that, you should also think about it this way. So this is a trip. Like trip always has a direction, right? From home, I started and I came to down to my work. So this was my direction. So directionality is important. We have to resolve that. That's what we will do in trip generation. So home-based trip, if I start a trip, either begin or ends in my home. That's how we define in transportation modeling home-based trips. It's not just begin. Either begin or end. So if I start from home, coming to the work, that's a home-based trip. If I start from home, work, but coming back to my home, that's a home-based trip too. Okay? A non-home-based trip is the trip which neither begins nor ends at home. Meaning from here to my bank, from here to my upper campus for Synod meeting. So those are my non-home-based trips. So there is no anchor to my home. So that's how we start doing that. There is some benefits of doing that because usually homes are the generator and the workplaces are the attractors. So it's easy to do that. So now, trip production definition is, like when we talk number of trips produced by each zone, right? That's our main goal in the trip generation.